Hello everyone, the next reaction in which alcohol is showing acidic behavior is with acid anhydride. Let's check the general formula of acid anhydrides. That is RCOOCOR, where R groups can be alkyl, they can be aryl, or one can be alkyl or other can be aryl. Two carbonyl groups are there, one mid oxygen is there. All oxygens are carrying 2 lone pairs. Now let's check how it reacts with alcohol. When alcohol reacts with acid anhydride, they create ester and carboxylic acid. Now carboxylic acid is a side product which will try to shift reaction in backward direction, so it is important to neutralize it. So to neutralize it, we are going to use a base pyridine, which we have used with acid chloride also. It will neutralize carboxylic acid and reaction will move in forward direction and lot of ester will generate. So generally, if I will write this reaction, it will be something like this. Hydrogen, which is a partially positive, you know why it is partially positive. Lot of time we have discussed it. These carbons are partially positive because oxygen are more electronegative than carbon. So they are getting electrons toward it. Partially positive it is. This oxygen is partially negative. These are partially negative, negative, positive, negative. So this H you have to join here with this oxygen. Bond will break. Now from which side bond will break, it depends on R group. During mechanism, I will discuss it. So let's break it. So H will combine with this part. So side product will be, you can check R, C, O, and H. Means R, C, O, OH. Which compound it is? Carboxylic acid, side product. Plus, this oxygen will break bond from hydrogen and will combine with this C. So I'm going to join them, R, C, O, and OR, ester. This one. So carboxylic acid and ester will generate out. Carboxylic acid will be neutralized by pyridine, which is working as a base there. So now let's check the mechanism of it. Mechanism. Step 1. Carbonyl groups are there in which carbon is carrying partial positive charge, oxygens are carrying partial negative, partial positive. Means these carbons are electrophiles. Can be attacked by electrons. But wait, which carbon? Which carbon is more electrophilic? It is decided by R group. R groups are showing plus I effect. Means R groups are donating electrons toward these carbons. How they are delivering electrons already we have discussed in previous videos also, so you can check it. So which we call plus I effect. Now plus I effect depends on size of R group. Bigger R group will show more plus I effect, means more movement of electrons toward carbon. Smaller R groups will show less plus I effect, means less movement toward carbon side. Electrons movement toward carbon side. Now suppose, let's assume this R group is small and this R group is bigger. Now due to bigger R group, more plus I effect will be there, due to which movement of electrons toward this carbon will be very, very high. Now because don't you think electrons are coming toward carbon, so its positive charge will decrease? Yes. positive charge will decrease too much, and from small side less positive plus I effect will be there. Less plus I effect means less movement of electrons toward this carbon, so its positive charge will decrease up to lesser extent. That's it. This is the main point function of R group here. So out of these two carbons, which is more positive? It will be more positive as compared to this, because less electrons are coming toward it. Its positive charge is decreased up to lesser extent, and its positive charge is decreased up to large extent. So this is more positive. More positive means more electrophilic. More electrophilic means it have a more chances to be attacked by electrons. So please understand this point, very, very important. Out of two carbonyl carbons, which carbon will be attacked by nucleophile? Or which carbon is more electrophilic? It depends on size of R group. Everything is written here, you can check it. Now let's start the whole process. What we have assumed that this R is small and this R is bigger. So this carbon will be more positive and this will be less positive. Now because this carbon is electrophilic, more electrophilic. Electrophilic means wants electron. Who can provide electrons? Alcohol. Alcohol is ready. Oxygen is there, lone pairs are available, because oxygen is also carrying a negative charge, because electrons are shifted toward oxygen due to higher electronegativity, negative particle. So this oxygen will prefer to attack on this carbon, not on this carbon. This carbon will attack because it is more positive, more electrophilic. With a pair of electron, it will attack on it. What will happen? Obviously, carbon can make maximum 4 bonds. So fourth bond will break, that will be pi bond, and pi electrons will shift toward oxygen side and an intermediate will generate. This oxygen will make dative bond with this carbon because vacant orbital is generated over there due to shiftage of pi electron. That vacant orbital will be filled by lone pair of oxygen. So I am going to make whole compound over here. Please check this part as it is. Here we will have changes. Check carefully. Because this oxygen is making dative bond, so obviously one electron out of two, one electron it will shift toward carbon side, this one, and one electron it will keep it with self. So plus one charge will generate over there. And pi electrons are shifted toward oxygen, so 3 pairs will come because oxygen is getting extra electron of the carbon, so it will carry now -1 charge. This intermediate will generate. Now in second step, you will check how this intermediate will stabilize itself because a lot of instability is there. Let's check. Step 2. That intermediate I am going to write. It was this one. Where we have instability, here we have instability. In previous mechanisms also we have understood it. This oxygen will break bond from hydrogen and both electrons will shift toward oxygen because oxygen is more electronegative than hydrogen. Let's write it properly so it will be visible to you clearly like this. Due to which this hydrogen will release out as H positive. Now please check, this was alcoholic particle is releasing H positive, means alcohol is working as an acid there but indirectly. So after this release, your molecule will become The mechanism is similar like that of acid chloride, only the leaving group is changed. Rest part is as it is. It will release out like this one. Is it stable? No, still it have problem. What problem? On single carbon, 3 oxygens are there with lone pair, lot of steric hindrance. So obviously one oxygen will leave out the molecule. Which oxygen have more chances? Look at this part. This part. A bigger part over there, so obviously creating lot of steric hindrance, it have a chance to get released out more as compared to this OR part. So when this oxygen will break bond from carbon, obviously electrons will completely shift toward oxygen because oxygen is more electronegative. Carbon will have vacant orbital. That vacant orbital will be satisfied by oxygen by shifting this pair of electron toward carbon, because this pair is creating instability on this oxygen, negative charge. So after this, we will get, this is a leaving group. Let's break this bond. So oxygen will get how many pairs now? This oxygen, 3 pairs with a negative charge, because 1 electron was of carbon, which it has got. Now this O negative will be satisfied by H positive, and check what is generated. RCOOH, carboxylic acid. Carboxylic acid. And what about this part? Let's check what happened over there. This oxygen is shifting bond over here. So between this carbon and this oxygen, 2 pairs of lone pair, 2 bonds will generate. R is there. This OR as it is. Which compound is generated? RCOOR. Ester it is. So ester and carboxylic acid, in this fashion they are getting generated during the mechanism or a reaction of alcohol with acid anhydrides. This carboxylic acid we will neutralize with the help of a base, pyridine, which we have also used in previous video when alcohol was reacting with acid chlorides. That's it. This is the end of the mechanism. Thank you very much for watching the video.